When a total solar eclipse rolls around, every eye and camera lens point straight up at the sky. But the most alien sights happen much lower, on the dirt beneath our feet. Under a tree right before the moon covers the sun, the ordinary, dappled blobs of sunlight scattered across the ground transform. They become thousands of tiny, perfectly shaped crescents. Your own shadow changes as well. If you hold your hand out, the shadow around your fingers looks soft and blurry. But rotate your hand exactly 90 degrees, and those edges instantly become razor sharp. In the final fleeting seconds before total darkness, a rare effect often emerges: faint, snake-like bands of shadow, rippling and racing across plane surfaces. An eclipse temporarily disrupts the everyday rules of optics, turning the surface of the Earth into a giant physics lab. It seems impossible that random gaps between tree leaves, or even a star-shaped hole punched in cardboard, could all produce the exact same crescent shadow. The secret is the distance between the hole and the ground. When a hole is held high enough, it stops projecting its own shape and begins projecting an image of the light source itself. Light travels in straight lines, so a ray leaving the top edge of the sun angles downward through that gap. A left ray crosses to the right. Left flips right, top flips bottom, meaning ground crescents point the opposite way as the sun. During an eclipse, every tree canopy transforms into an array of natural pinhole cameras, broadcasting the sun's hidden geometry onto the Earth. This geometry also explains why a single hand can cast a shadow that is both blurry and perfectly sharp at the same time. Usually, the wide sun sends light from many angles, casting overlapping shadows with fuzzy gradients. But right before totality, it's reduced to a thin vertical sliver. It remains wide enough vertically to maintain blurry edges, but horizontally becomes a single point, making vertical edges sharp. The physical shape of the light source dictates how light wraps around three-dimensional objects, turning every vertical edge into a direct reflection of the sun's current orientation. In the final seconds before totality, the moon's jagged mountains create a final optical effect. As sunlight is blocked by the peaks, it breaks apart into isolated, intense points of light called Bailey's beads. These narrow beams travel through our atmosphere, where layers of varying temperature and density distort the light. Because the moon creates several separate light points at once, these refracted beams overlap and interfere on the ground, creating the rippling snake effect. This is essentially the twinkling of stars, magnified by lunar mountains and projected across our planet. There is one last optical illusion to clear up. The moment the sun vanishes and the corona flares out, the light reveals its actual state: pure, blinding white. The yellow and orange colors we associate with the sun are an artificial artifact. To view a partial eclipse safely, we have to use specific filters, and the dyes in those films are what colorize the light. The sun's true color is white. It is simply too intense to look at without protection until the exact moment of totality removes the glare. With the moon finally in place, the ethereal, stark white corona becomes visible to the naked human eye. This window of pure white light allowed early scientists to study the sun's actual composition, leading to the discovery of a new element. They named it helium, after Helios, the Greek god of the sun. Witness the event across every surface. Watch the trees, wave your hands, track the rippling shadows across the pavement as the world transitions into darkness. A total solar eclipse is a rare alignment that briefly exposes the invisible rules of light governing our universe every single day.